Alrighty, guys, section 6. We're going to solve equations of the form x squared plus bx plus c equals 0. So previously, we multiplied binomials using what's called the FOIL method. Today, we're going to talk about how to factor trinomials of the form x squared plus bx plus c. In the last lesson, we did binomials of x squared plus bx. And all we did was factor out an x, and you would get x plus b equals 0, and then you set each one equal to 0 there. But this one, we have a third term plus c, and notice it doesn't have an x, it just has a constant. So you can't take an x out of all three terms, so you can't like undistribute an x from everything. But we'll show you what to do. And then we're also going to solve equations when the same trinomial is set equal to 0. All right, so, and that's called a quadratic equation. So you've learned how to multiply two binomials using the FOIL method. And each of the binomials was a factor of the product. The pattern for multiplying two binomials can be used to factor certain types of trinomials. So remember, using the FOIL method, x plus 3 times x plus 4, you did the firsts, and you get x squared, you do the outers, you get 4x, you do the inners, that would be the last. You do the inners, you get 3x, and you do the last, you get 3 times 4, or 12. Okay, so you get 4 terms, but notice the two middle ones add together. But notice that the 4 and 3 show up here, and you're going to be able to add those because they're like terms. And the 3 and 4 show up here, and it's the product of them. So you're going to add these two together, and you get x squared plus 7x plus 12. Notice the 7 came from adding the 4x and 3x, and the 12 came from multiplying the 3 and 4. Alrighty. So observe the following pattern in this multiplication. So you have x plus 3 times x plus 4 is x squared plus 4 plus 3x plus 3 times 4. In general, if you have x plus a number times x plus another number, the first term is always going to be x squared. The outer and the inner are going to add together. So you're going to add the m plus p times x. And then you're going to multiply the last, which is just going to be m times p. Okay, so in general, the first term's x squared, the middle term's going to be the sum of these two numbers times x, and the last term's going to be the product of those two numbers. Well, we can use that information to go backwards and factor. So notice that the coefficient of the middle term is the sum of m and p, like you just add m and p, and the last term is the product of m and p. You just multiply m and p. And that pattern, like I was just saying, can be used to factor trinomials where you have x squared plus a number times x plus c. Okay, so for example, if you had x squared plus 6x plus 8, that would be x plus 2 times x plus 4, because the 2 plus 4 give you 6, and the 2 times 4 give you 8. All right? So when c is positive, its factors have the same sign. So when this number right here is positive, its factors have the same sign. So they're either both positive or both negative, because 2 negatives multiplied give you a positive, and 2 positives multiplied give you a positive. So both of the factors are positive or negative depends upon the sign of b, the middle number. So if b is positive, that came from adding two numbers, and if the 8's positive, that came from multiplying two numbers. Well, the only way you can multiply two numbers and add two numbers and get positive answers for both of those is if both of the numbers are positive. If the last number is positive and the middle number is negative, then the only way that can happen is when you multiply two numbers and get a positive and add the two same numbers and get a negative, is if both numbers are negative. So here's an example. If I want to factor x squared plus 9x plus 20, let me just completely simplify this for you. What you really have to do is look at the last number and find the factors of that number, just write them down, and then see which ones add up to 9. So since this one is positive and the 9 is positive, I know the two numbers have to multiply to a positive and add to a positive, so both numbers are positive. So I don't need to consider like -1 times -20 or -4 times -5, because those are going to, while they multiply to positive 20, they're not going to add to a positive number. All right, so I just list the factors. So 1 and 20, 2 and 10, 4 and 5. And I add them up and see which ones add to 9. Notice the last ones add to 9. So that means I use 4 and 5 for my m and p, and x squared plus 9x plus 20 you can factor as x plus 4 times x plus 5. Now you can check that by just foiling it out. If you FOIL out x plus 4 times x plus 5, you do firsts give you x squared, outers x times 5 give you 5x, inners 4 times x gives you 4x, and lasts 4 times 5 gives you 20. The 5x and the 4x add together to give you 9. Okay? So if you factor, always check it by foiling to see if you got the right answer. All right, here's 2 for you to try. Go ahead and pause the video. All right, we're back. So this one, I need 2 factors that multiply to 24 and add to 11. So I could do 1 and 24, but that adds to 25. I could do 2 and 12, but that adds to 14. I could do 3 and 8, and that adds to 11. So my answer would be d plus 3 times d plus 8. Now that's my answer, but I could check it by foiling. If I do the first, you get d squared, outers 8d, inners 3d, and lasts 24. And that would simplify to d squared plus 11d plus 24. So I know my answer is right. The second one, they kind of threw a trick at you. It's not written in standard form, so you want to rewrite it in standard form as t squared plus 10t plus 9. Now I need factors of 9 that add to 10. So I could do 9 and 1, and those add up to 10. All right, I know to use positive factors because they have to multiply to positive 9 and add to positive 10. So I would do t plus 9 and t plus 1. Now I will say if you wrote it as t plus 1 and t plus 9, that's correct also. It doesn't matter because remember, when you multiply, it doesn't matter which order you multiply, you're still going to get the same answer. For example, 3 times 4 is 12 and 4 times 3 is 12. Oops. Okay, so if I check this by foiling, firsts give me t squared, outers give me 1t, inners give me 9t, lasts give me 9, and that simplifies to t squared plus 10t plus 9. Cool beans. All right, so when factoring a trinomial in which b is negative and c is positive, use what you know about the products of binomials to narrow the list of possible factors. So for example, if I want to factor x squared minus 8x plus 12, I can also confirm my answer using a graphing calculator. I'll walk you through how to do that. It's pretty simple. Okay, so notice the 12 is positive, so I need 2 numbers that multiply to a positive, but they have to add to a negative. The only way that happens is if both the numbers are negative. So I'm going to list the factors of 12, but list them as negative factors, like -1 and -12, but those add -13. -2 and -6, those do add to -8. The other factor could have been -3 and -4, but those add to -7. So you could have stopped right here. We just listed them all out to show you. So what that would look like is x minus 2 times x minus 6. And what you do on your graphing calculator is you graph both answers. You graph the original equation and you graph the factored form. And both graphs should overlap. So you turn your calculator on, go to the y equals menu. If stuff is in there, just clear it off. And the first one is x squared minus 8x plus 12. Put that in y1. And then the second one, you have to do parentheses. So parentheses x minus 2 parentheses times parentheses x minus 6. And if those truly are the same thing, because all I did was rewrite the trinomial in its factored form, it should be the same thing, then when I graph it, the graph should overlap. Okay, so if I hit zoom, zoom 6 is the standard viewing window. So it's going to graph the first one, and then graph the second one. Nothing happened. Well, something did happen because it graphed it over top of itself. Okay, let me just show you. If I changed this to a -1 and this to a -12, okay, like I use these two factors accidentally. This is the original one. It's going to graph that first, and then it's going to graph the other one and see it's wrong. It goes down here, and it actually comes up over here somewhere. Alrighty? So you should just show one graph if you did it correctly. All right, so here are two graphs, or two equations or two expressions for you to factor. Go ahead and pause the video. All right, we're back. Again, first one, you have to put in standard form, m squared minus 22m plus 21. All right, notice the constant is positive and the middle term is negative, so I need two numbers that multiply to a positive that add to a negative. The only way that happens is if both numbers are negative. Try -1 and -21. Those add to -22, so I don't even need to do any more work. I can just write m minus 1 times m minus 21. Okay, and if we FOIL those out, you will get m squared minus 1m minus 21m plus 21, and then the minus 1m and the minus 21m will add to -22m, and you get the right answer. Okay, this one, all right, got to get factors of 28. So 1, -1, and -28, that gives me -29. -2 and -14, that gives me -16. -7 and -4, that's going to give me -11. So that's the one I want. So it's going to be w minus 7 times w minus 11. And again, if you FOIL that, you would get w times w is w squared, and then you'd have -11w from the outers, -7w from the inners, which, see, that's why it's important to check. I accidentally wrote the 11 there and didn't see it till I checked it. It should have been -4. Okay, so let's do that FOIL again. So w times w is w squared, we're good there. W times -4 and -7w is going to give me -11w, and -7 times -4 gives me positive 28. So I know it's good. Okie dokie. All right, one more. When c is negative, its factors have opposite signs. To determine which factor is positive and which is negative, look at the sign of b. The factor with the greater absolute value has the same sign as b. Okay, that sounds a lot very complicated, but no, the last number, okay, the last number is negative. That means one number had to be positive and one had to be negative. The only way you multiply two numbers and get a negative is if one's negative and one's positive. Okay, so I need factors of 15. Well, you could list a whole bunch. You could have -1 and 15, or 1 and -15. Or you could have 3 and -5, or -3 and 5. You could have a big long list. But you can cut that list in half if you remember to look at this number. Since this number is positive, I know that I want factors where the bigger factor is positive. Okay, if this number was negative, I'd want the bigger factor to be negative. So since the bigger factor has to be positive, I could cut this one off, not that one. I could cut this one off and this one off, because those ones don't have the bigger factor that's positive. All right, so factors are -1 and 15, or -3 and 5. The -3 and 5 are the only ones that add to 2. So my polynomial factors as x minus 3 times x plus 5. And again, if you wrote it as x plus 5 times x minus 3, that would be okay. And just remember to FOIL it out or graph it to see if it works. And this one does. All right, this one. Notice here, the last term is negative, so I have to have a positive factor and a negative factor, but the middle number is negative, so the bigger factor has to be negative. All right, so you list out your factors of -18, and you only have to list the ones that have the bigger factor as the negative. So you wouldn't need to list -1 and 18, -2 and 9, -3 and 6. Don't need those because those aren't going to work. All right, so if you list these, you notice that 2 and -9 work. So those are going to be your factors, and you have x plus 2 times x minus 9. Again, if you FOILed that out, you would get x squared, then minus 9x plus 2x, which would simplify to -7x. Then the 2 times -9 would give you -18. Okey-doke. All right, here's 2 for you to try. Go ahead and pause the video. All right, we're back. Now let me say one other thing. Sometimes they might give you the polynomial like this. Okay, that's not in standard form, okay, because the constant term has to go last. All right, these ones are fine, but just wanted to point that out. So this one, -48, I need factors of -48 that add to a positive. So I know the bigger factor has to be positive. So 48 and -1, that would add up to 47. Okay, 24 and -2, well, that adds up to 22. Getting closer, but not quite there. 16 and -3. That's the one I got to use. So it's going to be y plus 16 and y minus 3. Again, if you FOILed that out, you get the right answer. Okay? So for this one, my factor is negative, or my last term's negative, so I need 2 factors, one positive, one negative. The middle number is negative, so I know my bigger factor has to be the -1. So -24 and +1 would give you -23. That's not going to work. -12 and 2, it gives you -10. Getting closer, but that's not going to work. -8 and 3 gives you -5. Closer still, but that's not going to work. And then -6 and 4 gives you -2. That one works. So also, it's not enough to just stop here. You have to actually write the factored form as x minus 6 times x plus 4. Okay? And again, if you FOIL this out, actually those were r's. Let me change them to r's. Don't want to get any confusion there. You FOIL it out, you would get r squared plus 4r minus 6r minus 24. And that would give you r squared minus 2r minus 24. Okay. All right, guys, that's it for this video. Stay tuned for the second half. We'll see you there.